Tara ascended a mountain at a constant rate of 125 meters per hour. After 4 hours, she reached an elevation of 1,700 meters. And we want to then find the linear equation that's going to give her elevation t hours since she started her climb. We can do this by saying our elevation is equal to our rate of change multiplied by the number of hours that have gone by, and then adding on the initial elevation to that. And now what I want to do here is take a look at what we have been given so far. Well, we have a constant rate of 125 meters per hour. That constant rate is telling us our slope. So our slope m is equal to 125. And it's a positive 125 because she is going up the mountain. We also have that after 4 hours, she reached 1,700 meters. So when t is equal to 4, the elevation, E, is equal to 1,700 meters. So this gives us a point on our line, 4, 1,700. What we don't have from this information is her initial height. That is something that we need to calculate to be able to find. So we want the equation, her elevation, is equal to m times t, the number of hours, plus b. Well, we have what m is. We know m is 125, and we also have a value that we can put in for t and e, that when t is 4, e is 1,700. And that's what we can then use to evaluate what her initial elevation is. So we have that 1,700 is equal to our slope of 125 times 4 plus that unknown initial height, which we're calling b. So now we can take this equation and solve this for b. A little bit of simplifying, we have 1,700 is equal to 500 plus b. And now we can subtract 500 from both sides. And we get 1,200 is equal to b. So the initial elevation is 1,200 meters. Now, this is what we can then use to write our equation for the linear model. We want E equal to mt plus b, and we have m and we have b. So our model is going to be E equal to 125t plus 1,200. And now the nice thing that we can do with these problems is we can double check to make sure that this is correct and working properly. We can do that by taking that point that we were given and putting that back in for t and e. So if I replace e in my equation that I have here with 1,700, 1,700 is equal to 125, and then replace t with 4 from that ordered pair, plus our initial amount of 1,200. And we get that 1,700 is equal to 500 plus 1,200. So 1,700 is equal to 1,700. So that matches out. It works. Everything seems good. And now we can use this to answer our last question here. What is her elevation after 7 hours? Well, this means we are replacing t in our equation with 7 and then evaluating. So E is equal to 125 times 7 plus 1200. So that gives us 875 plus 1200, which is then 2075 meters. So after 7 hours, we would expect her elevation to be 2075 meters.